Okay, so hi everyone. We are going to discuss our paper 6 probability statistics 2 for October November 2023 paper 6-2. So let's have a look for question number 1. Okay, so we are given a random variable x with this distribution. It is Poisson distributed with the lambda 25. So use the normal approximation. So I think they give us a very obvious keyword already here. So which is a normal approximation. That means you're going to change the Poisson become normal distribution to find out the probability of x greater than 30. Alright, so let's start. So to change Poisson become normal distribution, the condition is of course the lambda must be greater than 15. Alright, so in our example here, in our question here, the lambda already more than 15. Therefore, we can change it become normal distribution. So to change it become normal distribution, the first parameter in the normal bracket is mean, which is the lambda 25. And the second parameter in the normal distribution bracket is variance. So for Poisson distribution, we should know that the variance and also the mean are having the same value for Poisson distribution. So the lambda for this case is also 25, so which is also equals to variance. So our variance here will be equals to 25. Okay, right. So to find the probability for x greater than 30, okay, first of all, we need to know that Poisson is discrete random variable. Okay, and then the normal will be the continuous random variable. So when you want to change a discrete random variable to continuous random variable, right, you have to do some adjustment because for discrete, there are gap between the value of x, right? And then for continuous, the x is in range. There's no gap. Therefore, we need to do some small adjustment, and that adjustment you call it as continuity correction. Right, so for continuity correction, the step that we need to increase either plus 0.5 for the value or minus 0.5 for the value of x from the Poisson. Okay, so the way of decide whether is it a plus 0.5 or minus 0.5 has been included in a previous lecture video. So if you're interested to know some shortcut about how to decide the plus 0.5 and minus 0.5, I will put the link at the comment part. Then maybe you can have a look for the continuity correction there, right? So for this case, greater than 30, that means not included 30. So I want to include the value 31. For adjustment, it should be 30.5. Okay, so maybe the small rules that you need to know about the plus or minus 0.5, you can refer to the comment, the video link that I will put in the comment later, right? Okay, so after the continuity correction, this is what we have, 30.5. Okay, and now this is Poisson, and we change it become normal distribution. To find the probability for normal distribution, you have to standardize it become z, right? So you take 30.5 after the continuity correction, the value for x after the continuity correction, minus the mean, which is 25, divided by standard deviation, which is also square root 25. Okay, get the value for z up to 3 decimal places. So for this one, I think we get a very nice value, like 1.1. Okay, so to get the answer, to get the probability for z greater than 1.1, I think all of us should know that the area that we are interested is this part, right? Okay, and then because in our table, the normal distribution table, the area that it gives us is always smaller than, so the value that we get will be smaller than 1.1. So to get the small area here, I have to take 1 minus the value that I get from the normal distribution table. So I go back to the normal distribution table, look for 1.1. The value is this one, 8643, right? Okay, so go back to our solution here. So you have to take 1 minus 8643 because the 0.8643 is the large area here, the smaller than 1.1 area. Okay, so 1 minus 0.8643, and from here you should get the answer 0.1357. And for me, I prefer to change it become 3 significant figure, which is 0.136. Alright, yeah, so this is how we apply normal approximation on the Poisson distribution. Okay, alright, so let's continue to part number B. Okay, so for part number B, we are having the random variable y with the distribution binomial. 100 is the n, p is the probability, where p is smaller than 0.05. Use the Poisson approximation. So again, highlight the keyword Poisson approximation. They also give us a very obvious hint already. Okay, to the binomial distribution to write down expression in terms of p for y smaller than 3. So again, I'm having y as a binomial distribution. I'm having 100 and p. Now I want to change it become Poisson. Okay, so to get the lambda in Poisson, basically it is the mean. How to get the mean from binomial distribution? So to get the mean from binomial distribution, it is n times p, right? So n is 100, p is the p. So you take 100 times p, you get the lambda 100p here. Okay, so this is how you change binomial become Poisson distribution. So the condition for changing binomial to Poisson distribution, right, it should be np smaller than 5. N must be large, should be more than 50. Okay, then NB should be smaller than 5. So if you have a look for our condition here, right, N is already 100, which is more than equals to 50 already. And they actually did fix the value of P smaller than 0.05. So that when you take 0.05, any value smaller than 0.05, multiply with 100, you get NP smaller than 5. Okay, so actually they fulfill the condition. Right, so now, let's find out the probability for Y smaller than 3. Okay, so just a simple recall. Binomial is discrete random variable. Poisson is also discrete random variable. Therefore, there's not needed for us to apply continuity correction. Okay, so in part A just now, we apply continuity correction because of Poisson is discrete, normal is continuous. There are two different types of variables, so we have to do continuity correction. But for binomial to Poisson, they are both discrete, so no continuity correction is needed. Right. Okay, so how to find out the probability for y smaller equals to 3? Okay, so just to recall back again, what is the formula for Poisson distribution? So for Poisson, it is actually, if let's say I'm having y equals to r, the formula is e negative lambda, lambda power r divided by r factorial. Okay, so if I want to apply in y smaller equals to 3, right? Okay, so you can take e negative lambda, so lambda is 100p. Okay, so the first term is the probability x equals to 0. Oh, sorry, y equals to 0. If I want to have y equals to 0, then suppose it should be 100p power 0 divided by 0 factorial, right? According to the formula I show you here. Okay, then anything power 0 divided by 0 factorial, it is always a 1. So the first value for p, y equals to 0, x equals to 0, the value on the right, this one is always a 1. Then plus, when x equals to 1, the value is always negative, is always the lambda. Because lambda power 1 divided by 1 factorial, so it should be a lambda. Okay, so e negative lambda, I already pull it out, factorize it out. So this is for x equals to 1. And then for x equals to 2, I'm having lambda square. So lambda square divided by 2 factorial. So I should stop here because they said y smaller than 3, not included 3. So I should stop at y equals to 2. Okay, then we do some simplification. So we are having 1 plus 100 p. So expand the term in this one. So by right, we should have 5000 p squared. So this is how we find out the probability in terms of p by using Poisson distribution. Okay, yeah, so this is how we solve question number. Okay, so question number 2. We are having the length in minutes for mathematics lectures in a certain college with the mean mu and also the standard deviation 8.3. So the total length of a random sample of 85 lectures was 4590 minutes. Calculate a 95% confidence interval for the population mean. Okay, so for this question, we want to get the confidence interval for population mean. What's the general formula for population mean confidence interval? So the lower limit is sample mean minus the mu, sample mean minus the z, okay, multiply with sigma over square root n. Then the upper limit is sample mean plus z sigma over square root n. So this is the lower limit and also the upper limit for confidence interval for proportion, the population mean. Okay, sorry. Right, so let's have a look for all the values here, right? So we need to calculate the sample mean first. So sample mean, we can use the sample value 4950 summation of x divided by the n. Then sigma, what is the sigma? Sigma means the population standard deviation. So it is given in the question, which is 8.3. Alright, then n is the sample size also been given. Then the value of z is depends on the percentage, the confidence level that we are interested, which is 95%. So we need to find the z by using the 95% later. Right. Okay, so let us try to set up the question slowly. Okay, so first of all, I want to get the sample mean first, which is 4590 divided by 85. So the sample mean value should be 54, right? Okay, so you already get the sample mean value. So now I want to get the value of z. Okay, so to get the value of z, right, it depends on the confidence interval that we have. So for your information, if you want to calculate the confidence interval, yeah, the confidence level actually means the percentage in the center part of the graph, which is 95%. So 95% means this center part here should be 0.95. And since our normal distribution curve, they are symmetry to each other, right? So both ends were having the same area, where this is 0.025 and this one is also 0.025. Okay, so I want to get the value of z from this part. This is negative z. So to get the value of z, I need to consider the area below the z. So what's the green color area here? The whole green color area here. So the total is 0.975, right? You take 0.025 plus 0.95. Therefore, we should look for 0.975 for the value of z. Okay, so how can we look for 0.975 to get the value of z? So again, if you go back to the normal distribution table, you can get the 0.975 from this part and then find out the value for the z. Okay, but for me, I prefer to use the shortcut table here. So if you have a look, there's a shortcut table. Do you see the value for 0.975 at this part? And they already match the value of z for you. So from here, you can see very obvious, the value of z is 1.96. Okay, right, so we go back to our solution here. Okay, so I know that my z is equals to 1.96. Okay, so after everything we get, all the value that we get is ready, so we can try to put it inside the formula for confidence interval. So the 95% confidence interval for mu, what should it be? It should be sample mean 54 minus the z. Okay, so sigma is given in the question, which is 8.3 divided by the sample size. What is the sample size here? So again, sample size is 85. Okay, then 54 plus 1.6 multiply with 8.3 divided by square root 85. Okay, all right, then try to find out the answer. So for me, I directly correct it to 3 significant figure. So the answer should be 52.2 and also 55.8. Okay, of course, when you press the calculator, the value should be very long. Right, so we should correct our final answer correct to 3 significant figure, yeah? So by right, this is the final answer, correct to 3 significant figure. Okay, so this is how we answer part A. Then let us continue to part number B. Okay, so for part B, they are saying that just now we are talking about the maths lectures, right? So now they are talking about the history lectures. So the history lectures have mean M and also the standard deviation S. So use a random sample of 100 history lectures. The 95% confidence interval for M was found to have the width 2.8 minutes. So find the value of S. Okay, so you don't have the population mean, you don't have the value for the population standard deviation. You have 100. So 100 here is actually the sample size M. You have the confidence interval 95%. Then they are giving you the width of the confidence interval, which is 2.8. So let's have a look what is the width for confidence interval. So we go back to our part A just now. Just now I have shown you the formula for the confidence interval, right? This is the lower limit and this is the upper limit. Therefore, the difference between the upper limit and the lower limit is actually the width. So if you take upper limit, minus the lower limit here. So you have the formula 2z sigma over square root n for a confidence interval for population mean. Okay, so how to get the width again? So you take upper limit minus the lower limit. So I take the formula upper limit minus the formula for lower limit. This is what I get. So that's why I will use this formula for the width in the confidence interval and apply it in part number B. Okay, right, so let's continue further. Alright, so I'm using the formula of width equals to 2z sigma over square root n. So we now want to slowly put in all the value that we know. Okay, so what is the width here? So the width here basically is given 2.8. What's the z? So the value of z, you refer to the confidence interval given here. It is still referring to the 95% confidence interval. Therefore, the value of z is the same like what we have just now. For 95% confidence interval, the z is 1.96. So I use back the 1.96. What is the standard deviation for the population? So in this question, standard deviation is not given, and we want to find out the standard deviation as divided by square root n. So what is the square root n that you have here? Your n is 100 given in the question as well. So square root n will be square root 100. So again, you try to move all the values here and there slowly. So by right, you should be able to get the value of s, which is 50 over 7 in the exact form. Or if you want, you can change it become 3 significant figure, which is 7.14. Okay, yeah, so this is how we solve question number 2. Right, so now we are at question number 3. There's a researcher read a magazine article which stated the boys age 1 to 3 prefer green to orange, and then it is claimed that when offered a green cube and an orange cube to play with, the boy is more likely to choose the green one. More likely. So it's a keyword to help us to form hypothesis, alternative hypothesis later. This kind of question usually is about hypothesis test. So you should look for all the keywords to help you in deciding the alternative hypothesis. Alright, so more likely is one of the keywords. Okay, and then the researcher disagrees with this claim. She believes that the boys of this age are equally likely. So the researcher believes is equally likely. But there's another magazine, the article in the magazine, they believe that it is more likely to choose the green one. Okay, so in order to test the belief, the researcher carried out a hypothesis test at the 5% significance level. The alpha is 5%. She offered a green cube and orange cube to each of the 10 randomly chosen boys aged 1 to 3, and then recorded the number of x that the boy who chose the green cube. Out of the 10 boys, 8 chose the green cube. Okay, so assuming that the researcher's belief is either the color cube is equally likely to be chosen is valid, so a student correctly calculates that the probability x equals to 8 is this value, correct to 3 significant figure. So he says that because this value is less than 0.05, the null hypothesis should be rejected. So explain why this statement is incorrect. So for this question, they tell you that by using the p, x equals to 8, as the p value is incorrect. Why is this incorrect? So they are assuming this is p value. Excuse me. But when we are doing any hypothesis test, right? By right, our rejection region should be an area. So let's say this is x, 0 until 10. We are having a binomial distribution from 0 until 10. 10 boys, right? Okay, so they said this is the 8. So they try to calculate the probability on this line. So they say that this particular probability is actually the p-value, and they use it to compare it with alpha. So basically the concept is wrong, because when we want to calculate the p-value, we should get the area, okay, either greater than the observed value or either smaller than the observed value. So 8 is the observed value in the question. So to calculate the p-value, right, if this is 8, that means that if you want to calculate the p-value, right, it should be including the whole area after the 8. If that means 8 is on the right hand side, we are having the one tail test on the right, more likely. So if you want to calculate the p-value, we should include the whole area on the right hand side for the 8. So to use p equals to 8, the probability x equals to 8 as a p-value is not correct. You should include the greater than. Alright, so that's That's the reason why the statement is incorrect, right? So you can just tell them that we actually need to calculate the probability for x equals to 8 is needed to get the p-value. But not the equals to 8 only. Okay, it's the whole area, but not the particular own value for the p-value, right? Okay, so that's the reason. So let's continue to part number 2. They want us to carry out the test on researcher's claim. Either the color cube is equally likely to be chosen. So they want us to carry out the test. Right, so for this one, again, so we will try to write out a very simple steps to recall. What are the steps you have to be included in carry out the hypothesis test? So this is to test about the proportion, population proportion. So first step, you have to set up the null and alternative hypothesis. Secondly, you have to calculate the p-value, okay, by using a suitable distribution. Okay, then the third one, of course, you have to compare it with the alpha, p-value with alpha. And after that, the fourth step, of course, you need to make decision and also write out a conclusion statement in the context of the question. So these are the 4 steps that must be included in your when you are carrying out the hypothesis test, right? So let's start. First step, you need to set up the null and alternative hypothesis. Okay, so they are testing about whether the probability is equally likely or not. If let's say orange and green are equally likely to be chosen, so the probability should be 0.5. So this one is the researcher's claim, that means the probability being chosen, the green cube and orange cube being chosen is equally likely. So which is p equals to 0.5. But from the magazine, they believe that it is more likely. So more likely means greater than, right? So it should be a one-tailed test on alternative hypothesis, which is greater than 0.5. So this is the first step. Second step, when we want to calculate the p-value and we are going to test on the population proportion, basically we have to apply binomial distribution. So you have a look here, our sample size is large, which is, sample size is small, which is 10 boys. So our n is 10 and our p is 0.5. So we are using binomial distribution. So like what I told you just now, to calculate the p-value, right, we have to use x greater equals to 8. So let's calculate the p-value here. X greater equals to 8. So greater equals to 8 means we should start from 10C8. Okay, then 0.5 power 2 and 0.5 power 8. Total is 0.5 power 10. So I didn't separate it, so I just try it in a shortcut way. So 10C9, x equals to 9, 0.5 power 9 power 10. Then 10C10, 0.5 power 10. Okay, alright, then just use calculator to help you a little bit. The value that you get is 0.546875, sorry, 75. And I correct it to 3 significant figures, it should be 0.0547. So please take note that you are aware this is your p-value. Yeah? Okay, so next time I want to compare it with the alpha so that I can make the final decision. Okay, so here I draw a diagram for you. This is not the correct diagram, so please don't show this in the exam solution. But it is mainly for understanding. When I'm having x from 0 until 10, it is a binomial distribution, right? The graph is not the correct diagram, yeah? It is just help you to visualize it only. Right, so what is our rejection region? Our alternative hypothesis is on the right-hand side. Therefore, our rejection region is on the right. So this is our rejection region. So I highlight our rejection region here first. So the rejection area, this rejection region, what is the area of this rejection region? It is actually the alpha. So let's have a look for the alpha in this question. So they are using 5% as the alpha, the significance level alpha. That means our rejection region is 5%. So this whole thing is 0.05. The area is 0.05. So if you have a look for our p-value here, it is 0.0547. This area will be greater than 0.05, right? So you want to put it in the graph. So this area should be slightly greater than 0.05. If you put it within the 0.05, that means smaller. But now our value is larger, so the area should be more than, okay? The area that you draw should be greater than 0.05. And this particular x is your Okay, so 8 greater, the area greater equals to 8 is more than the alpha. So from here, you can see that the 8 falls under the white color part, which is acceptance region. Correct or not? Yeah, so what you can do now is you try to compare it first. Since our p-value, okay, so which is 0.0547, is actually greater than the alpha, which is 0.05. And if you try to visualize it by using the diagram here, which is not the correct one, please don't show this in exam, right? You can see that x falls under the acceptance region. Therefore, your conclusion will be do not reject the null hypothesis. Okay, it falls under the acceptance region. So what we do is like we are going to conclude as do not reject the null hypothesis. If we do not reject the null hypothesis, what is the conclusion here? So that means yeah, we trying to accept back our null hypothesis, correct or not? Or you can make a simple conclusion like this one. It has, so maybe you should write like this one. There's no sufficient, there is insufficient evidence to show that boys age 1 to 3 prefer green to orange. Okay, so usually what we do about the conclusion is, as long as you have a statement that's more or less having the same meaning like what we want to show, then it is okay. So for me, I'm using there's insufficient evidence to show that the boy age 1 to 3 prefer green to orange. So prefer green to orange means this one. But there's not enough evidence or not enough proof to show that this is correct. So therefore, my conclusion is something like this. Okay, all right. So this is how we carry out the test for this probability proportion or population proportion. Sorry. Right. So you are having 4 steps here. First step, second step, calculate the p-value. Third step, compare with the alpha, and the fourth step is make a decision and write out a statement in the context of the question, which is related to the conclusion. All right. Yeah. So let's have a look for part B in question number 3. Another researcher claims that type 1 error was made in carrying out the test. So I explain why this cannot be true. Okay, so why type 1 error cannot be made in this question? So you should know the definition of a type 1 error, right? So what's the definition for type 1 error? Type 1 error means what? Type 1 error means that you reject the null hypothesis when null hypothesis is true. Okay, so the condition is you have to reject your null hypothesis. Only you possible to make a type 1 error. All right, then in this test, do we reject the null hypothesis? No, right? We actually fail to reject or do not reject the null hypothesis. So in this test, null hypothesis was not rejected. Therefore, this is not true. Rejected. Okay, yeah, so that's the reason. Okay, then after that, for part C, in a similar test at the 5% significance level, so was carried out later using 10 another randomly chosen boys age 1 to 3. They wanted to find the probability of a type 1 error. Okay, so again, to find out the type 1 error, the definition is reject the null hypothesis when null hypothesis is true. Okay, so to find out the probability for type 1 error, right? This part, reject the null hypothesis, we need to know what is the rejection region. So where's the rejection region that we have? Okay, so we have to go back for part A to look for our rejection region just now when we carry out the test. Okay, so you can see that when I carry out the test, if I calculate x greater equals to 8, this is my p-value, but I'm aware that x equals to 8, the 8 itself falls under the acceptance region, right? So x greater equals to 8, the whole area is more than 0.05. Now I want to have a look. If let's say I want to know where's my x equals to 9. Is my x equals to 9 inside the rejection region or outside the rejection region? So what can we do here is we take x greater equals to 8, which is 0.0547, minus x equals to 8. So x equals to 8 is 0.0439. So you take this one, minus 0.0439. Okay, so what's the answer that you get for this part? So 0.0547 minus 0.0439. The value that you get is actually a small value, 0.0108. Okay, so it is actually 0.0108 if you directly minus. Okay, all right, yeah. So that means the 9 is already falls under the rejection region. So 9 onwards will be rejection region. 8 is still under the acceptance. Therefore, my rejection region in this part should be x greater equals to 9. Okay, then given that null hypothesis is true, means that p is equals to 0.5. Okay, so of course, if you want, you can use your result directly from first part to do the calculation. That means you take 0.0, what we have just now, 0.0547 minus 0.0439, 547 and 439. Okay, so 0.0547 minus 0.0439. So from there, you get 0.0108. Okay, so this is your type 1 error. That means you directly use all the value from first part just now. Okay, or maybe some students, they don't want to use the value directly. They want to use the probability, okay, the formula to calculate the probability. So x greater equals to 9. That means you have to start with x equals to 9. So 10C9, 0.5 power 10. Okay, then 10C10, 0.5 power 10 as well. So you are including the probability for x equals to 9 and also the x equals to 10. So from here, if you use the formula and you calculate it down by right, you should get 0.0107. So both answers are accepted in the marking scheme actually, right? So if you use the formula to calculate directly, so this is the value that you should get. And if you use the value from part A that we do just now, right? So the answer should be 0.0108. So this is how we calculate the type 1 error in this question. Okay, all right, so this is how we answer question number. Okay, so let's discuss question number 4. We are having the height in meters for the trees of a certain variety is normally distributed. So kindly highlight the keyword normally distributed with standard deviation 0.67. So this sentence basically tell us that we are having a population which is normally distributed and the population standard deviation is known, which is 0.67. Okay, so in order to test whether the population mean of H is greater than 4.23, highlight the keyword greater. From here, you also can see the word test already, right? So this is about a test, hypothesis test question. Therefore, we actually need the keyword, right, to help us and set up the alternative hypothesis. So the word greater is the word that help us to set up the alternative hypothesis later, right? The height of the random sample of 200 trees are measured. So they want you to write down the suitable null and alternative hypothesis for the test. Okay, so what is the null hypothesis? So for null hypothesis, we are knowing that the height is actually 4.23 meters all around. Then how about the alternative hypothesis? So for alternative, the word greater than gives us a hint where the mu should be more than, greater than 4.23 meters. Okay, so this is how we set up the null and also the alternative hypothesis. So the word greater is a keyword for us to help us for the alternative hypothesis. Okay, then after that, they are asking the sample mean of height h bar meters of the 200 trees is found and the test is carried out. So they started to carry out the test. The result of the test is to reject the null hypothesis at the 5% significance level. So reject the null hypothesis at 5% significance level. Find the set of possible value of h bar. Okay, so basically for this question, right, they're asking us for rejection region. All right, so let's have a look from the diagram first here. Okay, so for this test, it is normally distributed, right? So we're having a normal graph. So where is the rejection region that we have? So basically, this is alternative hypothesis. It is a one-tail test on the right. Therefore, our rejection region will be on the right. So that means our rejection region will be somewhere on the right-hand side. And this whole thing will be my rejection region. So how big is my rejection region? Basically, it depends on the significance level, which is 5%. So this whole area basically is 0.05. Okay, yeah, so now if I already know that this is 0.05, right, I want to know is this value of Z, and we call this as critical value. Okay, so I call this as critical value. How to find the critical value? You can actually get it from the normal distribution table. So this critical value is the value of Z, yeah. Alright, instead of looking for the area 0.05, because of a normal distribution table, they didn't provide us the value of Z based on the small area. So you have to look for the large area, which is complement of the 0.05. So what is the complement of the 0.05 area? So it should be 0.95. So instead of looking for 0.05, I'm looking for 0.95 for the value of Z. So go back to the normal distribution table. You can get the 0.95 from somewhere here, then find out the value of Z. But again, I prefer to use the shortcut formula. So for this shortcut formula again, I'm looking for 0.95. So you can see that, 0.95 is the area and the value of Z provided is 1.645. Therefore, go back to my solution just now. From here, I know that my Z value, the critical value is 1.645. Okay, all right, so now from this diagram, right, we know that if your test statistic is more than 1.645, that means your test statistic fall under the rejection area, then you will reject the null hypothesis. Okay, so from the diagram, I know that if my test statistic is greater than 1.645, okay, then we will reject the null hypothesis. Therefore, I will put it as this one, reject the null hypothesis when we are having the Z is greater than 1.645. Okay, so some students might ask, should I include the equal sign or not? For normal distribution, question, right, it is a continuous random variable. Therefore, you put greater or greater equals, there's no difference. All right, yeah, so it depends on you whether you want to put greater or greater equals. In the marking scheme I have checked just now, they basically accept both with the equal sign and without equal sign. All right, so I know that I reject the null hypothesis when the test statistic is more than 1.645. So what is the formula for the test statistic here? So by right, it should be sample mean minus the population mean divided by standard deviation over square root n is greater than 1.645. So we slowly input all the values that we know here. What is the population mean? It is the null hypothesis value that we are testing, which is 4.23. What is the standard deviation? So the standard deviation of the population is provided just now, 0.67. So we include here 0.67 divided by square root n. So what is the sample size that we have? So sample size we are having here is 200. So divided by square root 200, greater than 1.645. All right, then just try to move all the values to the right hand side. Okay, by right you should get the value 4.307933774 is a very long value. Therefore, I will cut it short into three significant figure, which is 4.31. So my sample mean must be having the value greater than 4.31. Okay, then only we will reject the null hypothesis, right? But of course, just to let you know that if you double check with the marking scheme, they basically also accept h bar greater equals to 4.31. Because for this question, it is normally distributed question. So for continuous random variable, basically equal and no equal sign makes no difference, right? Okay, so this is how we answer the part B. Okay, all right, so you maybe can try to link it with the diagram of the rejection region so that you know what are you going to find, right? Okay, so let's continue to part number C. So for part number C, Ajit said in B, we had to assume that the H bar is normally distributed, so it was necessary to use the central limit theorem. Okay, so why explain whether you agree with Ajit or not. So let us talk about the central limit theorem first. When are we going to apply central limit theorem? We have to apply central limit theorem if the population distribution is unknown, or it is not normal. I would say it is not normal or unknown. Okay, or not normal. If the population distribution is not normal, then we have to ensure that the sample size is large. Okay, then only we can have, or we can assume that the sampling distribution is approximately normal. So this is what we have for central limit theorem. If let's say we want to apply central limit theorem, we have to ensure that, oh, actually the population distribution is not given, or maybe we don't know what is the distribution, or maybe it is not normal. It can be binomial, possible, or whatsoever. But if you want to change it become normal, right, in your sampling distribution, so you have to make sure that the sample size is large, and we apply the central limit theorem at that condition, under that condition. But now if you look at our question here, our population is already stated clearly that it is normally distributed. So if my population is normally distributed, basically we no need to apply central limit theorem. Okay, all right. So for this question, basically we will not agree with what Ajit said. All right, so we are not agree with what Ajit said. Okay, so if let's say you want to tell the examiner, or maybe tell out the reason. Okay, so the population is normally distributed. Okay, so it's normally distributed. Therefore, the sampling distribution, okay, or maybe the H bar, therefore, H bar, okay, is approximately, okay, this normally distributed as well, okay, regardless to the sample size. Okay, so we are not applying the central limit theorem. So central limit theorem is not used, or is not needed. Okay, so this is how we actually answer the part C. Right. Okay, so we are at question number 5 now. The random variable x has a probability density function given by something like this, a function like this, and then x is defined from a until b. So a and b are all positive constants. It is given that the expected value for x is ln 2, and they want us to show that b is equals to 2a. Alright, so to get b equals to 2a, right, maybe we can directly start with the information provided in this question. So they are telling us that the expected value for x is equals to ln 2, which means that how to get the expected value for x in a continuous random variable, you have to integrate the range for the domain given for the x, and then you have to multiply x with the function first. So multiply x with the function 1 over x squared to get the expected value for the x. Okay, then it is equals to ln 2. Okay, so by right, after you simplify them, you have ln x, 1 over x equals to ln 2. Then now let us integrate 1 over x. Integrate 1 over x, we are having ln x. Substitute in the limit b and a into ln 2, into the ln x. So you're having ln b minus ln a equals to ln 2. Then you can combine ln b minus ln a become ln b over a equals to ln 2. This is the property of the ln function, right? Okay, so directly compare them. You can have b over a equals to 2, and by right you are seeing the answer very clearly now. Okay, b equals to 2a. Alright, then now let's proceed to part B. For part B, now they want you to show that a is equals to half. Since we already know that b is equals to 2a, right? We can use the property of the continuous random variable function, where if you integrate from a until b, for the function itself, the answer is equals to 1 because the whole probability under the area should be equals to 1, right? So we are going to use that result to get the value for a. Okay, so I know that integrate from a until b for my function 1 over x squared should be equals to 1. And since I know now the b is equals to 2a, right? I directly substitute b as 2a. Okay, then x power 2, 1 over x power 2 can be written as x power negative 2. So let's start this, integrate the function. Power plus 1 become negative 1 divided by the new power. Then 2a equals to 1. And I'm having negative 1 over x. Then 2a equals to 1. Substitute the 2a inside the value of x. So you're having negative 1 over 2a. So minus negative 1 over a. And it is equals to 1. Right, so for this question, basically you're having negative half plus 1. So negative half plus 1, what do you get? Negative half plus 1, you should get a positive half, right? So you're having 1 over 2a equals to 1. A is the denominator still, yeah? All right, so try to move the a to the right hand side. So you're having a equals to half. This is how you get the value of a. Then how about for part C? Part C, they want you to find the median of x. Okay, so to find the median of x, I know that if I try to get the area from a is half until the median, I put it as m. Okay, so if I integrate for the lowest limit, okay, the lower limit of the function until the median, the area that I get should be equal to 0.5 because median cover 50% of the data from the lowest limit until the median. So I'm using the integration from lowest limit until the median for the function I get, and I let it equal to 0.5. Okay, or there's another option. Some students, they prefer to integrate from m until b. So b is equals to 2a. Since you know that a is half, right? So you can integrate from m until 1. Also can. Then you let the function equals to 0.5. So it is up to you which one you want to use. So both of this solution can lead you to the correct final answer. Okay, right. So integrate negative x power negative 2 again. So I'm having negative 1 over x. The integration is exactly the same like what we have just now. Right, just that now my limit is median and also half equals to 0.5. So I substitute the median in, I'm having negative 1 over m. Then minus, if I substitute the negative half inside the x, I'm having negative 2. So equals to 0.5. Right, so 1 over m is equals to 2 minus 0.5. Therefore, okay, so your m is actually 3 over 2 here. 1 over m is equal to 3 over 2, therefore your m is equals to 2 over 3. Or if you want to make it become 3 significant figure, it should be 0.667. Okay, so just to double check whether your m is the correct answer or not, you can maybe check in a simple way where you double check, is it 2 over 3 beside your lower and upper limit? So your lower limit is half, upper limit is 1, right? So 2 over 3 is between these two values. So very likely your answer should be the correct one. Alright, so this is just a small step or maybe small technique to check whether your m is correct or wrong. If your m is less than half and also more than 1, definitely your answer is wrong. Okay. Alright, so this is how we solve question number. So question number 6. There's a factory makes the bread in batch, and then one batch of the loaf contain X kilogram of dry yeast and also Y kilogram of flour, where X and Y have independent distribution. So both the X and also the Y are normally distributed. Okay, then the dry yeast costs 13.5 per kilogram, flour costs 0.90 per kilogram. For making one batch of bread, the total of other costs is 55. Alright, then the factory sells each batch of bread for 200. Then find the probability that the profit made on one randomly chosen batch of bread is greater than 40. Okay, so for this question, it looks like, well, it is very complicated because you are having so many different things inside the question. So maybe we try to figure out first, we are having the kilogram of yeast and also Y kilogram of flour, right? And all of these will actually contribute to the cost of the bread, right? So we are having the cost from X and also the cost from Y. Okay, so what else do we have? We also have other costs, which is 55. So the cost for the yeast depends on how many kilograms of yeast are we using, and also the cost of flour depends on how many kilograms of flour are we using. But there's a fixed cost there, which is 55, without referring or without depending on X or Y. But all these are the costs. Okay, so all these are the costs. And after that, we have another thing here. We are having 200. So the 200 here, I will call as revenue. That means the income, right? Because they are selling the bread for 200. Alright, so this is the revenue or income. And after that, for this question, they are interested for the profit made. So the profit made here, they are saying that it's greater than 40. Okay, so there are three important groups here. So we are having cost, we are having revenue, and also we are having the profit. So just a very basic knowledge, So how to get the profit basically? So to get the profit, by right, it should be equals to what? The revenue minus the cost, right? Okay, so minus the cost. Alright, so they want to have profit greater than 40. So they want to have profit greater than 40. So that means your revenue minus the cost should be greater than 40. So this is a probability that they want us to find out. Okay, but before you can find the probability, of course, you have to set the question first, right? So what is the revenue? So revenue means 200 minus the cost. What are the costs that we have? So we have the cost from the yeast, which is 13.5 multiplied with the X. Okay, it depends on what is the weight, okay, for the X that we are using for one batch of bread. And then besides the yeast, we are also having the cost from the flour. So from the flour, it is 0.90 per kilogram. So it depends on the weight of using the flour. The flour is used. And after that, we still have the fixed cost, which is 55 for one batch of bread. So you have to minus 55 greater than 40. So basically, this is the probability that they want us to calculate. Okay, and before we can calculate the probability, since we know all the X and Y here are normally distributed, therefore all the linear combination here of the X and Y is also normally distributed. And now we have to find out the mean and also the variance for the equation that we have here, so that we can continue to calculate the probability. Alright, so here the problems come. Okay, so for this question, there are many mean and also there are many means and also the calculation method that is accepted, okay, to get the correct answer. All right, so some students, they prefer to group everything together. That means they put 200 minus 13.5x minus 0.9y minus 55 minus 40, then greater than 0. They move everything to one side, then they simplify the equation on the left. So if you try to simplify the equation on the left, then you're having 200 minus 55 minus 40. So it becomes 105. So 105 minus 13.5x minus 0.9y greater than 0. Then they try to find out the mean for 105 minus 13.5x minus 0.9y and also the variance. Then after that, they calculate the probability. So this is one way. All right. And then some students, they might prefer to only focus on this one first. They try to get the cost first. So if you want to get the cost first, so some students, they might want to calculate the mean for 13.5, okay, then plus 0.9y, then plus 55. This is the cost, mean for the cost and also the variance of the cost. Then only they substitute it into the equation and get the probability. Also can. Alright. So there are many ways for you to show the calculation and to get the probability. All the value of mean might be different, but no matter how you move all your value here, right, your variance will be always the same. No matter this variance or this variance, they're always the same. Okay, all right. So just to let you know, first, okay, in advance first, where for this question, there are many ways for you to find the mean and also the variance. Mean value might be different. Okay, but for variance, no matter how you shift all your equation here, the variance value are always the same. All right, so let's discuss what am I using here. Okay, so for me personally, I'm finding out the mean and also the variance for cost first. All right, so I need to erase everything here, yeah? So if you need to refer back the step, you can just pause the video first. All right, so I know that profit is equal to revenue minus the cost. Okay, so first of all, what I do is that I try to set up the total cost formula first. So what is my total cost formula? So my total cost, I put it as T. So T can be written as what? It is equals to 13.5x, then plus 0.9y, then plus 55. This is the cost for one batch of bread, the total cost for one batch of bread. So now I want to calculate the mean for the total cost. Okay, so to get the mean for the total cost, it should be 13.5 multiplied with the mean of x, which is 0.7. Okay, you can refer back to the normal distribution given here. 0.7 is the mean for x, then plus 0.9. What is the mean for y? So the mean for y will be 100. Okay, then the mean of 55 remain as 55. Okay, so from here, again, the mean of the total cost, which is 154.45. All right, then after that, for the variance. So if I want to calculate the variance for the total cost, I need to take out the 13.5 and I square it. When you want to take out any variance, the constant from the variance, right? Okay, the multiply constant from the variance, you have to square it. So I'm having 13.5 square, okay, times the variance of the x. So the variance of x is this one, 0.02 square, plus 0.9 square multiply with the variance of the flood, which is the y, is 3.0 square. So multiply with 3.0 square. Variance of a constant, variance of 55 always give you a 0. So please take note on that, yeah? Always give you a 0. Therefore, your variance should be 7.3649. Oh, sorry, it's not 3649. It should be 3649. Okay, yeah, so this is the mean and also the variance for my total cost. Okay, since all the x and y here are normally distributed, therefore I know my total cost is also normally distributed with the mean 154.45 and also the variance should be 7.3629. Okay, do you still remember that just now I showed you some other calculation for the mean and variance, right? If you include all the revenue, cost, and also the profit in your calculation, the mean might be different. I didn't go and find it out, but the mean should be different, okay? And if you use the, just now, you include everything in calculation and the variance, it is still the same, which is 7.3629. Only the mean will be different, right? So please double check if let's say you're using some other formula, okay, or maybe some other equation before you calculate the probability. So please be aware, okay, that the mean can be different, but the variance are always the same. Right, so this is the mean and variance for my total cost. Okay, then now, if I continue with the calculation for the probability, what they want us to calculate the probability that the profit is greater than 40. So if they want to find out profit is greater than 40, like what I showed you just now, profit means revenue, which is 200 minus the cost. So my cost is the T, right? Then greater than 40. Okay, then because I calculate the mean and also the variance for the T, therefore I want to make the T as the main object where I'm having T is smaller than 160. That means my total cost should be less than 160 so that the profit that I get will be more than 40. Okay, then T, I know that it is normally distributed, therefore I have to change it become Z. I have to standardize it. So I take 160 minus the mean. What's my mean here? So minus 154.45 divided by standard deviation. So what's standard deviation here? Square root 37.3629. Okay, then try to get 3 decimal place for the value of Z. It should be 2.045. Okay, then let's have a look for 2.045. 2.04 is here, then 5 is this value, right? So I have to take 9793 plus 2 at the last digit. So you're having 9795. Okay, so go back to our question here. So Z smaller than 2.045 will be 0.9795. Or you can correct it to 3 significant figure, which is 980. Okay, so this is how I answer the question here. Alright, so for me, I am taking the T, the total cost, as the main object, and then we are trying to standardize it from the T. Okay, so therefore I get the mean for the T and also the variance for the T first. Alright, yeah, so this is how we solve question number 6. Alright, so the last question for this paper, question number 7. A random variable X has the distribution of Poisson with the lambda 2.4. Find the probability of X is from 2 inclusive until 4. So I think this is quite straightforward. If we want to calculate the probability from X between 2 until 4, right? Because Poisson is discrete random variable, so X have to take all the integer. So integer between 2 until 4 should be X equals to 2 and also X equals to 3 only. So how to calculate the probability from Poisson distribution? In case you really forget the formula, right? It is provided in the formula booklet, which is this one. Okay, E negative lambda power of R divided by R factorial. Maybe I can show you here. Okay, we are using the probability E negative lambda power R divided by R factorial. Okay, where the lambda means the mean in the Poisson, in the parameter. Okay, of the Poisson distribution. So for x equals to 2, I'm having e negative lambda, which is 2.4, then lambda power 2, so 2.4 power 2 divided by 2 factorial. And also for x power 3, I'm having also e negative lambda, right? Therefore, I factorize out the e negative lambda outside. Then I'm having lambda power 3 divided by 3 factorial. Let's try to use calculator to help us a little bit. Alright, then if you didn't do any careless mistake, you should get 0.470 correct to 3 significant figure. Alright, answer should be very long one, yeah? So we cut it short into 3 significant figure as a standard answer. Yeah, so question number 1 is very straightforward, right? Okay, then let's have a look for part B. For part B, now they are saying that there are 2 independent values of x are chosen. Find the probability that both these values are greater than 1. Both are greater than 1. So we are having 2. And then highlight the keyword independent values. So when the values are independent, that means you can directly multiply their probability together to get the answer. So I'm having x greater than 1. The second variable also I'm having x greater than 1. How to calculate the probability for x greater than 1? For Poisson distribution, basically you cannot calculate the greater one because greater means that you have to start from x equals to 2, then including x equals to 3, x equals to 4, and so on until infinity. So it is impossible and very long for us to get the answer. Therefore, I have to take 1 minus. So that means for x greater than 1, I have to take 1 minus x smaller equals to 1. Same thing for the second x. So I have to take also 1 minus the probability of x smaller equals to 1. Since you can see that both of them are the same, therefore you can actually make it as square. So some students might write it into this way, where 1 minus the probability x smaller equals to 1, and they just square it. Also can, right? Okay, then now let's input the value for here. So 1 minus, for x smaller equals to 1, that means you're having e negative lambda. Then for the first term, x equals to 0, the first term is always a 1. For x equals to 1, the value is always the lambda. Oh, sorry, I have to put in the lambda here, which is 2.4. Put it bigger. So 2.4. So first term is always a 1. The second term is always a lambda. The 1 here is for x equals to 0. Okay, lambda power 0 divided by 0 factorial, it is a 1. Then this is for x equals to 1. If we are having lambda power 1 divided by 1 factorial. Okay, then I directly take out the e negative lambda because every single term here is having e negative lambda, right? Yeah, so I have to minus this one and then I have to square them. Okay, of course, if you didn't do any careless mistake by pressing calculator, by right, the answer that you get should be 0.478. Correct to 3 significant figure as well. So this is how we answer part number B. And let's proceed to part C. For part C, they give us information x equals to r is smaller than x equals to r plus 1. Find the set of possible values of r. So to find the r, right, we have to start from the information given by the question, which is this one. Okay, so let's start. The probability for x equals to r is smaller than the probability of x equals to r plus 1. So first of all, we have to write out the formula, right? So we are having e. For the probability x equals to r, the formula will be e negative lambda power r divided by r factorial. Then for x equals to r plus 1, it will be e negative lambda. Then you're having lambda power r plus 1. Okay, so to get the value of r, maybe I have to try and simplify all the inequality here first. E negative 2 or power negative 2.4, e power negative 2.4 can be cancelled off each other on the left and right hand side. And now for the 2.4 power r, I want to move it over to the right. It will become the denominator on the right hand side. Okay, then for the r plus 1 factorial, I will want to bring it up to the left hand side, become the numerator. So we are doing the cross multiplication. Okay, so I want to group all the r at here and all the value with 2.4 at this side is because of you can further simplify them. Okay, so let's talk about the easier one first, which is this one. Okay, so for 2.4 power r plus 1, it can be written as 2.4 power r multiplied with 2.4 power 1, right? Because we have learned this before. A power m multiplied with a power n is equals to a power m plus n. And we are going to apply in the reverse way. So 2.4 is the a, m plus n means r plus 1. So you can separate it, become a power m multiplied with a power n. Okay, then divided by 2.4 power r. So from here, again, you can see that we can simplify them. Okay, then let's talk about the r plus 1 factorial. When we are having factorial, right, we should know that, let's say we are having 10 factorial divided by 9 factorial. So how can we simplify 10 factorial divided by 9 factorial? So 10 factorial means 10 times 9 times 8 until 3, 2, 1, right? Then divided by 9 factorial means that 9 times 8, then until 3 and 2 and 1. Okay, sorry. Okay, so 3, 2, and 1. So from here, you can see that you can cancel off the 9 until 1 directly, left only the 10. So what's the difference between 10 and 9? They are 1. So that means if let's say 9 is r, then 10 will be r plus 1. Okay, so that means if we apply it in general, right? So I'm having r plus 1 factorial divided by r factorial. I should have something like r plus 1, which is the 10, then multiply with r factorial divided by r factorial. So this is small knowledge about the factorial where you should know about it as well. Some common sense on factorial knowledge, alright? So 9 until 1 is r factorial. So 9 until 1 is r factorial. Therefore, r and r factorial can be cancelled off and you left only r plus 1. So what we have in the inequality here also the same. I'm having r plus 1 here. Okay, so from here, I think you can see very clearly that r plus 1 should be smaller than 2.4. Hence, r should be smaller than 1.4. Okay, then when r is smaller than 1.4, let's have a look for this question again. We are talking about the Poisson distribution. And for Poisson distribution, all the value for r here should be integer. Correct or not? Okay, they are discrete now, so it should be integer for Poisson. Therefore, we have to list out what is the possible values of r. If let's say I'm having smaller than 1.4, so r can be equals to 1, and also r can be equals to 0. So r can take these two values where it is equals to 0 and also it is equals to 1. Okay, yeah, so this is the solution for part C number 1. Let's continue to part C number 2. They want you to find the value of r when px equals to r is greatest. Okay, so you can see that x can be equals to, r can be equals to 0 and also r can be equals to 1, right? Okay, so let's have a look from part B. Yeah? From part B, they have tell us that, oh, I'm having x equals to r smaller than the probability of x equals to r plus 1. Okay, then if my r is equals to 0, because I know that my r can be having two values, right? R equals to 0 or r equals to 1, right? Okay, if my r equals to 0, yeah, so the probability of x equals to 0 is smaller than the probability of x equals to 1, right? 0 plus 1 is a 1. And then if my r is equals to 1, then I'm having x equals to 1 smaller than the probability of x equals to 2. If you combine these two together, will give you the inequality where you know that x equals to 0 is smaller than x equals to 1, and x equals to 1 is smaller than x equals to 2. Can you have the probability of smaller than x equal to 3 or not? Actually cannot. Why? Because just now in part number 1, our answer is only applied for 0 and 1. So that means for 0 and 1, this inequality is correct. If you want to put r equals to 2, it is wrong. To get x equals to 3, you need to have r equals to 2, but our answer is not, r equals to 2 is not included in our answer just now, right, in part 1. Therefore, I only consider these two values of r. So these two values of r will give you only this inequality. So they are asking, which x equals to r has the greatest probability? So this is having with the greatest probability, right? And they are interested for the value of r probability. Therefore, the r should be equals to 2. So this one, that means the value of x equals to r is greater. So x equals to r, compare directly here, r should be equals to 2. Okay, so this is how we solve all the questions in this paper, and thank you very much for watching this video.